17. Andrew is thinking of a number. It is between 1 and 150. That's quite a lot of numbers to work with, so probably not the best one to start with. It is 1 more than a square number. Okay, that's pretty reasonable. It is 3 less than a cube number, and it is not a prime number. So let's start with it is 1 more than a square number. So square numbers are 1, for example. 1 times 1 gives you 1, so square number is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 13 times 13 is 169, which is too big. We only want numbers between 1 and 150. But remember, we're looking for 1 more than a square number. So these numbers need to be 1 larger. So 1 larger than 2, 1 larger than 1 is 2. 1 larger than 4 is 5, and so on and so forth. So we've already got a list of numbers it could be. We need to narrow it down a little bit further. So let's narrow it down again. Let's look at the next one on the list. It is 3 less than a cube number. So let's go through our cube numbers. So the first cube number would be 1 times 1 times 1, which gives us 1. Then we would have 2 times 2 times 2, which would be 8. Then we would have 3 times 3 times 3, which would be 27. 4 times 4 times 4 would be 64. 5 times 5 times 5 is 125. It's going to be 3 less than a cube number, so we need to take away 3 from each of these numbers. So 3 away from 1 would be -2. 3 away from 8 would be 5. 3 away from 27 would be 24. 3 away from 64 would be 61. And 3 away from 125 would be 122. So they're the actual numbers. And we know it's not a prime number. So now it's a process of elimination. So we need to find any numbers that occur in both of those lists. So we have the number 5 in both of those lists. We also have the number 122 in both of those lists. But importantly, it's not a prime number. And 5 is a prime number, so it's not 5. It must be 122.